Hi guys, my name's Jenna Grinvalds and I'm going to show you guys questions 4, 5, and 6 of the week 6 quiz. So number 4, you're going to find this algebraically. So I wrote out the steps. The first step is rewrite the improper integral as the limit of the definite integral. So basically what you do is you're going to write it in like a limit notation. So basically, you're saying that n is approaching infinity. So you basically replace infinity with n here, and then you just write out the integral. For step 2, work on the integral first using the fundamental theorem of calculus, find the antiderivative, and evaluate. So right here, what I did was I just took, because 1 over x to the 4th is the same as x to the negative 4th. So I just multiply 2 by x to the negative 4th. Moving on, when you take the antiderivative of this, you would get 1/3 over x to the negative 3. Or sorry, negative 1/3 over x to the negative 3. Multiply that by 2, you get negative 2/3 times x to the negative 3. And then you're going from 4 to n. So here, you plug in these two into these equations and subtract. So here we have negative 2/3 n instead of x to the negative 3 minus negative 2/3 times 4 to the negative 3. And then here I just put this in my calculator and got negative 0.0104. And then you put, what I did also is x to the n to the negative 3 is the same as 1 over n to the 3rd. So if you multiply those together, which leads into step 3, so you take the limit, 1 over n to the negative 3 is the same as 0 because n is approaching infinity, and if the bigger numbers that you put in for n, the closer to 0 it's going to get. So obviously multiply 0 by negative 2/3, you're going to get 0. And there's supposed to be a negative in front of this as well. So you add that, because minus a negative you add. So you get 0.0104 as the answer. Okay, so now for number 5, we're going to numerically estimate this integral. So step 1, rewrite the improper integral as the limit of the definite integral. So basically you just write it in the limit notation once again. Step number 2, you're going to set up a table of the definite integral values. And so right here it's asking us to do it to 1 decimal place. So we're going to add 2 extra decimal places to 3 decimal places. So basically what you're going to do is you're going to put it in your calculator into the y equals. You're going to go 40 to x and then second graph. And then you're just going to put in multiples of 10 and until you get 3 of the same number. So that's what I did here. I copied the values in. Step number 3, you're just going to round it to the requested number of decimal places, which ended up being 25.2. Alright, and for number 6, we're going to use algebraic manipulation to evaluate the improper integral. So first of all, I used the distribution, so x to the 0.2 times x to the negative 3, because 1 over x cubed is x to the negative 3. And then when you multiply the exponents, you basically just add them, so that equals x to the negative 2.8. Step 2, I used the algebraic method to find the improper integral, so we'll start there. You rewrite the improper integral as the limit of the definite integral, which basically you just write it in limit notation. And then step 3, work on the integral first using the fundamental theorem of calculus, and then find the antiderivatives and evaluate. So basically I found the antiderivative. So negative 2.8, you add 1 to the power, so negative 1 over 1.8 x to the negative 1.8, evaluated at n and 2. So then moving on, negative 1 over 1.8, you substitute n in for x to the negative 1.8, and then you evaluate the same at the value of 2 and then subtract the 2. And then I just put that in my calculator and I found negative 0.1519. And then here, n to the negative 1.8 is the same as 1 over n to the 1.8 multiplied by negative 1.8. Step 3, you take the limit. So this would be equal to 0 because as n approaches infinity, the bigger the number that you put in for n, the closer to 0 it's going to be. So 0 times negative 1 over 1.8 is obviously equal to 0. Minus negative 0.1519, you basically add it, and you get the answer of 0.1519.